generally. We often reflect foliar or root diseases in crops that have these same symptoms in mineral quantitative data. In other words, when we have high aluminum in the leaf data, we see oftentimes root diseases in below ground in the soil. And so when we find growers that have the inability to grow crops in quantitative data sets, again, we have a high aluminum, and we have a phosphate shortage. We have a high sulfur, we have a nitrogen shortage. We have a high sodium and a calcium shortage of availability. We see large amounts of water problems from sodium, nitrate, carbonate, or chloride. And in some cases, we see a chloride buildup in salt content over 30 to 50 years. And then at a certain point in time, the plant gives out. This is what happens when you have a natural resource such as cycled carbon that continually gets depleted through soluble nitrogen applications over many, many years. Over time, the chlorine continues to build up, the plant can't buffer it, and eventually it takes over. When we see rising expenses from a farmer and they're consistently complaining about the added inputs that they're needing to put out year over year, we oftentimes see that there's an excessive magnesium to other nutrients, specifically nitrogen. We see there's a large amount of sulfur, and that starts to depress the sulfur to nitrogen ratio. Again, back to the aluminum to phosphorus ratio, increasing your phosphate expense, or your calcium ratio is decreasing over time when, through overapplication of potassium, release of magnesium from latent soil environments, or release of sodium into the soil over time as well, locking out calcium, driving sodium, and driving potassium into the plant. For growers that are actually able to utilize the system correctly and have been able to achieve extreme successes in using the apical method of crop improvement, leaf analysis, crop inputs, data analysis, they're able to grow better crops with less fertilizer. We did an experiment last summer where we put 200 or 25 pounds of nitrogen on some growing blueberry plants, and we simultaneously put 2.5 pounds of nitrogen on the same blueberry plants and watched which one grew more. We actually had better growth where we put 2.5 pounds of nitrogen as opposed to 25 pounds of nitrogen. Now, there was a diverse feeding program that went into the 2.5 pounds of nitrogen, some microbes and some carbon sources and some other things, but it was half the cost of the 25 units of nitrogen. This was yet another confirmation that myself and other agronomists around the country and around the world are starting to realize is it's not a game of nitrogen units and getting the nitrogen units to your crop. Absolutely not. It's about getting your growth first in the opposite way with as little nitrogen as possible. So to do this, you focus on root health, right? I met some guy not too long ago. He said, "I just want to grow plant roots. Everything else will work out if I grow healthy plant roots." And he's correct. If you have white, healthy, vigorous plant roots growing at all times, the top of your plant will mimic that all day long, and vice versa. Oftentimes, when we see growers using carbon with nitrogen sources, they achieve this method, right? They achieve vigorous root growth rapidly. We also find that when growers begin to consider the larger physiological impacts of long-term farming practices through acids, herbicides, chemical buildup, and start to want to do some degree of detox, they're able to begin to immediately cut back on their crop inputs of fertilizer. When growers are accessing mycorrhizal fungi and nitrogen-fixing microbes and utilizing them correctly, we see those growers able to grow crops with less fertilizers. And last but not least, growers that are able to manage nutrient antagonisms on a week-to-week basis or month-to-month basis through leaf analysis. Carbon is king. Thanks again very much, and look forward to seeing you all next week. Take care.